Hello. In this video, we're going to continue our study of factoring polynomials. Now, we have this third degree polynomial, 12x cubed plus 4x squared minus 3x minus 1. And we can't factor it with our normal methods from previous years because, of course, the degree 3. If this term was missing and we just had degree 2, sure, we could use quadratic formula, group factoring, all sorts of things. But the degree 3 means we have to use our more advanced skills. And in particular, we're going to have to set up synthetic division. So we can draw like this, our 12, 4, minus 3, and minus 1. And we're going to need to guess at the right number to put here so that in the end we get 0 and we have a factor. Now go ahead and pause the video and give it a try. See if you can find the number you need to put there. All right, you might have found it a little bit difficult, and if you want another hint before I show you the answer, the number you're looking for isn't a whole number, it's going to be a fraction. All right, let's go ahead and try 1/2. Well, if we start with 1/2, 12 pops down. 1/2 times 12 is 6. 4 plus 6 is 10. 1/2 of 10 is 5. 5 plus negative 3 is 2, 1/2 of 2 is 1, and sure enough, we get our 0 remainder. So that means we could write x minus 1/2. Remember, we always flip the sign. Then 12x squared plus 10x plus 2. Now we keep going and we look for, our old skills, I should say, on this polynomial. We can take a 2 out, giving us 6x squared plus 5x plus 1. Now we're going to look for two numbers that multiply to give 6, right? Because it's going to be this 6 and the 1. So 6 times 1 is 6. And two numbers that add to give 5, that middle term. I'm thinking 2 and 3 look pretty good. 2 times 3 is 6, and 2 plus 3 is 5. So we break out that middle term as 2x and 3x. Then we factor out the 2x, giving us 3x plus 1. Here there's really nothing in common, so we can put a 1 as a placeholder, 3x plus 1. Then we factor the whole 3x plus 1 out of the expression, and we get 2x plus 1. Now for our final answer, of course, we need to keep everything else. So whether we write it at the end or whether we continue on each step, we definitely don't want to lose that x minus 1/2, and we certainly don't want to lose this 2 either. Those are both part of the final answer. So however we decide to do it, we definitely need to have our x minus 1/2 and our 2, and then we can box this as our final factored form. And again, if you're not sure it's the correct factoring, you can always go ahead and multiply it out. It'll definitely get back where you started. Although I'm sure some of you are wondering, Mr. Peters, how did you get this 1/2? You just seem to have plucked it out of thin air, and I mean, it worked, sure, but how am I supposed to come up with it? And if you look, the other numbers that would have worked are also pretty bad. If we look at our final answer, we can set each one of these factors to 0 to see the roots. So the first one here gives us x minus 1/2 equals 0. In other words, x equals 1/2. We get 3x plus 1 equals 0. In other words, x equals negative 1/3. And we get 2x plus 1 equals 0. Or in other words, x equals negative 1/2. So the only numbers that would have worked were 1/2, negative 1/3, and negative 1/2. Again, these are pretty tricky. They're not intuitive looking at this polynomial. And where do they come from? Well, we're going to go ahead and try another example, and we'll see what we come up with. There's probably some kind of pattern, probably some kind of insight, but it's not initially jumping out, at least not to me. So let's try factoring this polynomial. Again, because of the degree 3, we're going to need our skill of synthetic division. So we get 4, negative 3, negative 8, and 6. Now we're looking for that magic number that we put up here so that in the end you get a 0. And again, I encourage you to pause the video and give it a try. All right, well, it looks like the number we need is, well, I mean, maybe you found it, but if you were trying to be clever like the last time and tried 1/2 or tried 1/3, plus or minus, none of those work. And so in this case, I will promise you that it's a fraction, but it's not even going to be like a nice fraction. This is a super nasty answer. And I mean, if you were able to guess at it, props to you, but you probably weren't able to. I'm going to show you how to find the correct factor, or the correct root, I should say, that we can put in here. But to do that, we need to look at a few associated ideas. Let's look at that 6. 6 is the last number in our polynomials, the constant term. And we want to look at the factors of 6. This is a pretty easy question from a lot of grades past. The factors of 6 will be 1, 2, 3, and 6, the numbers that go in evenly to 6. And technically, when we're looking at factors, we do consider positives and negatives, but we'll get there in a second. Let's also look at the factors of the leading term, 4. What are the factors of 4? 1, 2, and 4. Well, the way we find our potential root is we have to take the factors of the 6 and we have to put them on top of a fraction. So it's sort of like you're constructing this fraction over here, and on the top you can put the factors of 6. On the bottom you can put the factors of 4, and then of course you can plus minus it. In other words, using a little bit of permutations combinations, because there's 2 options for the sign, plus or minus, and because there's 4 options for the factors of 6, and there's 3 options for the factors of 4, we're going to have 2 times 4 times 3, which is equal to a total of 24 possible roots. So there's actually 24 different fractions you would have to try, which, I mean, that's a lot of options. But the good news is that it's a concrete, finite number of options. If we were doing this in class, I'd probably have each group pick 2 or 3, and we'd be able to solve it pretty quick as a group because, I mean, 24 is a large number, sure, but if we split up the work amongst a few different people, I think we can get there. The possible options, again, if we write them out, we could take, for example, 1 on top and 1 on the bottom. Of course, plus or minus. We could take 2 on the top and 1 on the bottom, 3 on the top and 1 on the bottom, or 6 on the top and 1 on the bottom. These kind of simplify because dividing by 1 doesn't really do anything. So these are like trying plus minus 1, plus minus 2, plus minus 3, and plus minus 6. Okay, those are like the typical whole numbers you would try on a question like this. I'm going to tell you right now that none of those work, but I mean, it was a good try. So let's cross those out and let's look at maybe some fraction versions. Well, again, you take the factors of 6, so 1, and maybe we'll put it over 2 this time. So 1 over 2, 2 over 2, 3 over 2, and 6 over 2. Now, the nice thing is that 6 over 2 is actually 3, and that means we can cross it off because we've already tried the whole numbers, and I'm telling you they don't work. And 2 over 2, well, I mean, that's just 1, so we can cross that off. So we've got plus or minus a half and plus or minus 3/2. For the last one, we have the 4 on the bottom. So we have 1/4, 2/4, 3/4, and 6/4. Now the 2/4 is the same as a 1/2, so don't bother repeating that. So really, we're just looking at plus or minus a half, plus or minus 3/2, plus or minus a quarter, plus or minus 3/4, and again, 6/4 is the same as 3/2, so we can cross that one off. So while I did say there were 24 options, by writing them all out, we can see that there's really only 8 options because the whole numbers, we probably already tried them and they didn't work, and the other ones are, well, they look like they're different options when you simplify the fractions. They're the same thing. All right, enough stalling. Let's go ahead and try one of these. I'm going to try 3/4. Well, let's drop down that 4. 3/4 times 4 will be 3. Negative 3 plus 3 is 0. 0 times anything is 0. This gives us negative 8. That's going to give us, well, we might need to do a little bit of arithmetic on the side here. 3/4 times negative 8. It's going to be negative 24 over 4. Negative 6. Oh, looking good. That's going to give us 0. So we have x minus 3/4. 4x squared minus 8. Now again, we use our regular skills of factoring here. Factor out the 4. And this is just a difference of squares. I would say squares in air quotes because it's going to be x minus root 2 and x plus root 2. If you haven't seen that before, it's just using a difference of squares, but instead of it being a perfect square, 2 isn't a perfect square, so you just write root 2. Okay, well, there we have it. We have our final polynomial all perfectly factored. And what we needed to do was use this method here. Again, we have to look at the factors of the last term, divided by the factors of the first term, or the leading coefficient, and then we put a plus or minus. And this allows us to determine which numbers to check in our synthetic division. All right, I know that was a lot. Let's go ahead and try another example. And to start with, I would just like you to write out all the possible options for factors. I'll go ahead and tell you the one that's correct in a minute, but first just pause the video and write out the different options, right? You're looking at the factors of 8, you're looking at the factors of 3, and you're setting them up in a fraction. So write out all those options and see what you get. All right, so let's set up our synthetic here. And our options are, well, for 8, the factors are plus minus 1, plus minus 2, plus minus 4, plus minus 8. The factors of 3 are just 1 and 3. So we have 1 over 1, 1 over 3. Sorry, I'll keep it the same as last. 1 over 1, 2 over 1, 4 over 1, and 8 over 1, all plus minus. And 1 over 3, 2 over 3, 4 over 3, 8 over 3. So we can see a total of 16 options there to try. The one you want to try is negative 4 over 3. All right, here we go. 3 pops down, negative 4. 12. 12 times negative 4 over 3 will be, well, we could reduce the 12 with the 3 and give us 4, so that'll be negative 16. And then negative 4 over 3 times 6. Well, again, we could reduce the 6 to give us just a 2, so it'll be negative 8. And we get our 0. X plus 4/3, remember to flip the sign. 3x squared plus 12x plus 6. Then we factor the 3. X squared plus 4x plus 2. And finally, ooh, this is a little nasty. If I'm looking for two numbers that multiply to give 2 and add to give 4, the only numbers that multiply to 2 are 1 and 2, and those don't add to 4. Can we factor this? I think we can. Oh yeah, that's right. We're going to need to use that quadratic formula. So if you remember from previous years, when you have a quadratic that doesn't factor nicely, you probably have to grab this one. Minus b plus or minus the square root, b squared minus 4ac all over 2a. This is when you have ax squared, bx plus c. So in our quadratic, we can notice that the a is just a 1, the b is a 4, and the c is a 2. All right, let's rock and roll with the quadratic. So minus 4 plus or minus 4 squared minus 4 times 1 times 2, all over 2 times 1, minus 4 plus or minus 16 minus 8 over 2. So minus 4 plus or minus root 8 over 2. Ooh, root 8, I think we can simplify as 2 root 2, right? Because the root 8 is 4 times 2, and the square root of 4 is 2. Okay, well, we'll keep going here. 2 root 2 over 2. Now I can divide each term by 2. And so I'll have negative 2 plus or minus root 2. Okay, so this is what x equals, but I was writing it in the factored form. So this is, again, a little tricky at the very end here. X equals negative 2 plus root 2, and x equals negative 2 minus root 2 are our two x values. To convert them back into little factored things in brackets, we have to move everything to the other side. So if we move it to the other side, right, take the negative 2, move it over, it becomes positive. Take the positive root 2, it becomes negative. Same thing over here, we get x plus 2, and this will be plus root 2. So those are the two factors. Finally, we combine those with our initial x plus 4/3 and our 3 to get a final answer of x plus 4/3, 3, x plus 2 minus root 2, x plus 2 plus root 2. All right, so that used the formula for finding the possible roots. We used the quadratic formula. My goodness, what a question. All right, if that part with the quadratic formula was a bit too fast for you, here's an extra video I'd recommend you'd watch. I'll go ahead and throw a link to it in the description. This just gives you a more thorough explanation of the quadratic formula in case you need a little bit more review. Or you're welcome to look up any video just going through the basics of the quadratic formula. Let's go ahead and take some notes on this topic here. So again, what we're doing is factoring polynomials. And in particular, we're looking at polynomials where the degree is 3 or maybe even 4, and the leading term has a coefficient. So it's not simply x cubed plus 5x squared plus 2x plus 6, but there's maybe like a 3 or a 4 in front. There's some number in front. And when you have a situation like that, to find the possible roots, you have to do the following. The possible roots come from looking at the factors of 6 and the factors of 4, 1, 2, 3, and 6, 1, 2, and 4, making a fraction, and then putting plus minus in front of every single one of them. So for an example here, why don't you try 2x to the 4 plus 3x cubed minus x squared plus 12x minus 36. So you want to factor that down. If you get a little stuck with it, I'll give you a couple hints here. One of them will be a whole number. So there's a whole number root that you should be able to use. And there's also going to be one that is a fraction. And, well, if you get stuck, here's the hint. The fraction will be either plus or minus 3/2. Additionally, once you've finished factoring this, just be careful. Sometimes you end up with quadratics that don't factor. So something like this x squared minus 4, that always factors. It's x minus 2, x plus 2. It's called the difference of squares. But if you had something like x squared plus 9, well, that doesn't factor. Because, I mean, well, first off, it's plus instead of minus. But second, if you check the discriminant is b squared minus 4ac. The discriminant ends up being negative, which means therefore it doesn't factor. Therefore, it doesn't factor. Again, if you need a little bit of review on discriminant, go ahead and check out some videos on the quadratic formula. All right, hopefully you enjoyed that video. And as always, thanks for watching.